Recognize this face? This is Michael Faraday, who's just replaced William Shakespeare from the new 20-pound note. This man was of such enormous achievement that he transformed the world, and he did it here in the Royal Institution. The Royal Institution houses the oldest continuously used laboratory in the whole world. Since 1900, when Nobel Prizes were introduced, 15 of our scientists who have worked and researched here have won that prize. It has been said there are more Nobel Prizes per unit area registered at the Royal Institution than any place on Earth. This is the home of the greenhouse effect. It was discovered here deep in the last century. This is where molecular biology began. This is where the thermos flask and numerous other devices were invented. But the greatest discoveries of all made here were those made by my most famous predecessor, Michael Faraday, about 150 years ago. It was Faraday who discovered how to generate continuously electricity. He built the first dynamo. He built the first electric motor here in the Royal Institution, and by so doing, he lengthened our day, eased our manual labors, and indeed changed the nature, the very fabric of civilized life. In a famous experiment that he carried out in this very room in 1845, he demonstrated that electricity and magnetism and light were interconnected. By so doing, there emerged a totally new picture of the physical world. You see, a physical world that Newton had given us is capable of enabling us to predict celestial mechanics and the ebb and flow of the tides, but it could never give you the telephone and radio and television and the fax machine. Faraday's picture did. It is no wonder that Albert Einstein had a portrait of Michael Faraday on the wall of his Berlin study. How appropriate, because Einstein recognized that it was Faraday who was the prophet and the pioneer of the new picture of the physical world that enabled Einstein to do his work. But Faraday was also a chemist. He was professor of chemistry here for nearly 50 years. He was the man who discovered benzene, the very foundation of the chemical industry. More than 1 million tons of benzene are made annually in Britain now. They're used as the building block for pharmaceuticals and drugs, for polystyrene and for nylon. Faraday also founded the electrochemical industry, the world of batteries and of electroplating. But the most remarkable thing about Faraday is that he was self-taught. He knew no mathematics. He left school, son of a blacksmith. He left school at 13, became first an errand boy and then an apprentice to a bookbinder. He entered the Royal Institution in 1812 almost as a result of an accident. One of his employer's customers gave him tickets to come and listen to the most dazzling lecturer of the age, Sir Humphrey Davy. He listened transfixed to those lecture demonstrations. He promptly wrote them up as a book, presented it to Davy, who then hired him, first as a bottle washer and then as a chemical assistant. Within 18 months, he was accompanying Davy on a grand European tour, during which time they carried out many experiments. By 1824, Faraday was a Fellow of the Royal Society. Numerous other honors were to follow. Faraday was a deeply religious, highly self-disciplined man, full of humility. He also believed passionately in the importance of popularizing science, and he was particularly keen to devise spectacular lecture demonstrations for children. You see, Faraday wasn't just the greatest experimental scientist of all time. He was also one of the greatest communicators. The experiments you're about to see were first publicly demonstrated here on Faraday's bicentenary as a special lecture with the help of the Electricity Association.
Chin up. It's because the Prince Consort is here.
Oh, no. It's not royalty. It's just that I hope the children understand.
Hello, Uncle.
Good evening, niece. God, who has made all things, make me thy servant in showing their unity. Tonight, I shall bring before you what was once considered a beautiful dream. Nothing is too wonderful to be true if it be consistent with the laws of nature. And in such things as these, I believe experiment is the best test of such consistency. A glass rod, a feather, bring them together. Does anything happen? No. A piece of silk. If we rub the glass rod with the piece of silk. Now, this is nothing new. It's called electrostatic attraction. But where does the electric charge reside? Let us look at this. I built this for madmen, because only madmen go into it. As you see, it's a wooden frame held together by copper wire, so arranged that all metal parts are in contact. It's mounted on glass to insulate it from the floor, and next to the cage, you will see my frictional electric machine with which my assistant is going to electrify the cage, if you would be so kind. The cage is now being charged up, and so am I. I am electrified, but I can't feel anything. And even my most delicate instruments cannot detect any electric effect, and you can't see anything, because the charge remains outside. Whatever is happening is taking place between the surface of the cage and surroundings. Now, if my assistant would kindly discharge the electricity. The Queen.
No, it's me.
Oh.
must you work, Uncle?
Must I?
You're already rich and famous.
No, I'm not rich and famous.
Mama and Papa say you are.
Well, I'm not, and I work because I want.
Why?
Well, I came here as a young man, Constance, to earn my living, because my parents were poor. I cleaned that floor. And did you see him? He was my employer, Sir Humphrey Davy. You see his eyes? I wonder what he's thinking now,
He's thinking you haven't cleaned the floors properly.
What the great purpose is seems to be looming in the distance. The clouds are thinning. I cannot doubt that a glorious discovery in natural knowledge awaits our age. I pray I shall see it. The exertions in physical science of late years have been directed to ascertain the manner in which natural powers are linked together, the universality of each in its action, and their probable unity in one. Right, in you come. Oh, have one of these.
What are they?
These are lavender lozenges I'm trying to make for Mrs. Faraday. Oh, still some more work to do there, I see. Now, let me show you this.
What's this?
This is a battery invented by a man called Volta, who originally made a chemical source of electricity with this, Volta's pile. It's a pile of metal, zinc and silver, on top of each other, separated by pieces of paper soaked in salt water. I made one as an apprentice using zinc and some halfpennies, and you could make one too. Now, watch the needle.
It's jumping.
For joy. It tells us there is electricity. Now this is a development of that idea, but bigger and better.
But what does it do?
It provides chemical power for an electric current carried through these wires into these carbon rods to produce electric light. I made some ginger wine. Want some?
Yes, please.
I want the raisins.
Raisins.
Raisins. On the shelf. Do you remember the glass rod and the feather? The magnet is much heavier than the feather, isn't it?
Of course it is.
Remember I told you there's a relation between magnetism and electricity?
Can we see the potassium explode in the water?
In a minute. I want to show you something, though I don't think you're going to realize quite how exciting this is. Never mind. This shows the relation between them. It's Hans Oersted's experiment of a long time ago. He found that the wire carrying a current has an interaction with a magnet. And he pointed out that this interaction operates in a circle around the wire. Now, I wondered if this circular force could be used to produce mechanical movement. And this is my experiment. It's an electric motor. Now this is mercury in the basin. At the bottom is a piece of wax with a small upright bar magnet, the tip of which you can see standing above the surface. Now this hanging wire is connected to a current from the battery, and so is this wire, which is also attached to the side of the basin. Now watch. Do you know what this is? It is simply wonderful.
Can we see the potassium in the water now, sir?
Yes. Potassium in the water.
I love it. Pretty. Pretty close. Look at it comes.
You've not cheated. You've not lied.
I know.
They can't say that. I won't allow them to say it. I will not. As to the opinions which others may have of your conduct, that is your concern, not mine. How dare he? How dare he? You discovered it, not him.
Well, he expected the rotation.
He didn't invent an electric motor. You did.
He thinks I found what he was looking for.
Dr. Wollaston might look for cheese on the moon, but he'll never find it. You tried to tell him before you published. It wasn't your fault he was never at home. They're calling you a thief. Humphrey Davy's on his side now.
I think he feels I found the idea unconsciously. No, Sir Humphrey isn't against me.
Isn't he? Oh, well, good, that's good. So why is he opposing your election as Fellow of the Royal Society? I'm sorry.
Look, I think I've found a way to improve those lavender lozenges. You know, they'll be as good as any you get in the shops. You'll love them, promise. 29th of August, 1831. The most momentous discovery. I've had an iron ring made, 7/8 inches thick and 6 inches in external diameter. Coils of wire, insulated with twine and calico, are wound around one half, A. The other half, B, also wound with wire, is entirely separate from A. A connected to a battery, B to a galvanometer, and as I make the connection, current passes from the battery through A, producing a magnetic field in the ring, but the galvanometer needle connected to B is swinging. A current is induced in B, which is not connected to the battery. Now, if I disconnect the battery from A, the galvanometer needle swings in the opposite direction. Furthermore, I have found that the strength of the induced current in B depends upon the number of coils of wire. If the coils are increased on B, the electric force is stronger. Therefore, a large electric force can be transformed into a small one and the other way around.
The Prince has invited you to tea with him on Sunday.
Well, only because he wants me to give him a private lecture. You're hardly jealous.
No, I'm just thinking what the church elders might say.
I love you. I love nature. I love God. I love my country and my queen. If the elders have anything to say, then let them say it. I shall tell them that the tea is to discuss my work, which tries to link God's minerals and matter in a unity which was God's original creation. All I'm doing is trying to dispel ignorance, superstition, and fear of the unknown, and a cup of tea and a piece of cake is hardly likely to come between that knowledge and my church. Is it? How does the movement of the magnet create electricity? I entertain the idea that the spaces around the magnet were important. Let me show you this. The magnet is under the paper. You can see curves made by the iron filings, lines of magnetic force in a field, in the space around the magnet. It is the force field produced by the magnet which has powers on the metal only when moving, not when at rest. As the lines of force are cut by the metal, we have electricity.
You're being asked to become the president of the Royal Society. I've just heard. No, you can't turn down the presidency.
Something missing, is there?
Michael?
Sarah, my sweet, I've already turned down the presidency of the Chemical Society. No ill came of that.
That was different.
How can I be Michael Faraday if I'm president of the Royal Society? I mean, how can I be me? How can I be what I am? How can I go on doing what I am doing? I cannot. My brain would turn soft. I'd lose my mind. My work is here, not at dinners and flattery, drinking. It'd be chaos. I must have order. Besides, there's so much to do. Lavender lozenges are a devil to make properly. Ask Constance. I need all the time I can get. Tell me what's missing.
It is so absorbing and exciting to him that it often deprives him of his sleep, and I am quite content to be the pillow of his mind.
Now this is not my machine. It's a Hippolyte Pixie recently exhibited in Paris, but it was made and operates as a result of my discovery. This magnet rotates beneath these coils to produce in them an electric force. This is the very first practical electricity generator. In my next discourse, I shall demonstrate an interaction between magnetic force and light, and go on to try to show gravity's relation with electricity, light, and Dr. Wollaston, Prince Albert, Queen Victoria, John. What? I have long held an opinion, almost amounting to conviction, in common, I believe, with many lovers of natural knowledge, that the various forms under which the forces of matter are made manifest have one common origin. And working to this conclusion, I have at last proved that light is also affected by magnetism. Gentlemen, it is with the deepest feeling that I address you. I have been most happy with your kindness, but I am no longer competent to perform as I wish the delightful duty of teaching in the theatre of the Royal Institution. A gentle decay has overtaken me. My memory is not as it was. I have written the word retire in my notebook. I desire, therefore, to lay down this duty. My life's work has been devoted to finding the answer to the overriding question: how are all the wondrous forces of nature related? A grand unifying theory will one day be found. Indeed, Einstein succeeded where I failed, in showing that gravity can bend a ray of light. As members of the Royal Institution, you share my experiences, and I share your hopes that the pursuit of knowledge will transcend all evil, because in knowledge lies wisdom, peace, and a closeness with our universal Creator. God bless you all.